In this video, we are going to solve a few problems for the central limit theorem for proportions. Suppose that the true proportion of voters in the country who supports a specific candidate is 0.47. So this is the population proportion P. Consider the sampling distribution of the proportion of supporters with a sample size n equal 114. What is the mean of this distribution? So from the lecture, I talk about the central limit theorem for proportion, and we know from the lecture that if I take the mean of all the sample proportion, then I'm approaching to the value of the population proportion, or we are given here 0.47 for part A. And then they ask you, what is the standard error? The standard error is another way of asking for the standard deviations. So we also saw from the lecture the standard deviation. This one is the bias estimator. Therefore, it is not approaching to the population proportion, but it is the square root of the population proportion times 1 minus P divided by the sample size n. Or P we got here 1 minus 0.47 all over n, and in this case 114. And if you do that calculation, we should get 0.047. So that's the first problem. Straightforward and very easy. Now let's move on to the next one. The next question. So the next question. A food marketing institute found that 28% of the households spend more than $125 a week on groceries. And assuming that the population proportion is the small p, and a simple random sample of n, the sample size n, to be 112 households is selected from the population. They ask you, what is the probability that a sample proportion of the household spending more than $125 a week is less than 0.03? So the first thing is we must find what is the mean and what is the standard deviation of the sample proportion. So we can find the mean of the sample proportion, and this one is equal to the population proportion P, which is 0.28, and then the standard deviation, again from the previous problem, the same formula. Again, the standard deviation is the bias estimator. Therefore, you have to take the square root of P1 minus P. It is not simply equal to the population proportion. It has some adjustment here. All right. So if we do that, we will get 0.0254. Okay. N is 3112, P is 0.25. Okay. Now we can draw that using the curve. So we know that the mean 0.28 is at the center. This is the mean 0.28. Now they are looking for 0.3. So 0.3 is a little bit higher than 0.28, and you want less than 0.3. So we want the probability or the area below that 0.3. Okay, and you can find the area of the normal curve given the x value. You can find that using the TI-84 here. Let's do that. We can use the function of second distribution. This is a normal curve, and we're looking for the cumulative area here. So we use a normal CDF, and the lower bound is all the way from the left side, so you can just put a minus 99999, a very large negative value. And then the upper, we go up to 0.3. And then the mean is at the center, 0.28. The standard deviation is the one we got here. This is not a standard normal curve, so we are not having the mean at 0 and the standard deviation at 1. This is just a regular normal curve, and therefore if you paste that, you should get 0.78445, and you just route to 4 decimal places. Okay, so that is how we do this problem. Let's do the next one. In an election, suppose that 50%, so any time that we are given the percentage, consider that as a proportion. So suppose that 50% of voters support the incumbent candidates, and if we poll 167 of these voters at random, the probability distribution for the proportion of the poll voters that support the incumbent candidates can be modeled by the normal distribution picture below. Complete the boxes accurate to 2 decimal places. So how do I find what is this value, what is this value, and what is this value? Okay, so this is the normal curve. We know that this is the mean, the center, right, at the center, and this is 1 standard below the mean, this is 2 standard below the mean, and this is 1 standard above the mean, and 2 standard deviation above the mean. Now we are looking for this value, and this value, and this value. Okay, so again, this is the problem for the central limit theorem for proportion, and again, the mean of all the sample proportion is approaching to the population mean. Population proportion, P, and that is 50% or 0.50. This is the P value. And again, we can also find the standard error or the standard deviation, which is the square root of P 1 minus P all over N. And if you plug in this value, 0.5 times 1 minus 0.5 divided by N is 167, and you should end up with 0.03869 or around 0.04. Let's route to 2 decimal places. Right. So yes, the mean here is the center, which is 0.5. Now this is 1 standard deviation, 2 standard deviation above the mean. So this point here, we take 0.5, we plot 2 standard deviation. This is the standard deviation. This is 2 times. So we add 2 times 0.04, and that will give you 0.58. Now this is, we go back 2 standard deviation below the mean. So we're gonna take the mean 0.5 minus 2 times to the standard deviation, and that will give you 0.42. So that's, we just apply the normal curve, the characteristic of the normal curve. The mean, 1 standard deviation above the mean, and then 2 standard deviation above the mean, and so on. Okay, the last example in this problem. In an effort to cut the costs and improve the profits, any US companies have been turning to outsourcing. In fact, according to purchasing magazines, 54% of the companies surveyed outsourced some parts of their manufacturing process in the past 2 to 3 years. Suppose 555 of these companies are contacted. What is the probability percentage that 3A or more companies outsource some parts of their manufacturing process in the past 2 or 3 years? And round the percent to the 2 decimal places. So again, we are given the population proportion. This is P. And we have to find the mean. First, the mean of all the sample proportion is approaching to the population proportion, which is 0.54, convert back to decimal places. And then you can find the sigma of the sample mean, sample proportion, which is 1 P, 1 minus P all over the n, and here is 555. And then we can do that 0.54, 1 minus 0.54, all over 555. Let me get this number here, 0.54 times 1 minus 0.54 divide by 555, take the square root. I am getting 0.021 for the standard deviation. Let's do part A. Again, we can draw the normal curve. The mean is the value here, 0.54. Now they are looking for what is the probability percentage that 3A or more companies outsourced some parts of the manufacturing process in the past 2 to 3 years. Again, we have the sample of 555, and now we are looking for 3A out of 555. So let's find that ratio. Out of 555, 338 divide 555, you're gonna get 0.609. So we are 0.609 is above 0.54. So maybe put it here, 609, and we are looking for what is the percentage of that, or more. So or more, that means bigger than. So you are looking for the right area. Okay, the right area. The probability is the area. Now, how do I find the area to the right? Well, if I use the TR-84, I can do that very easy. Again, I can use second distribution. Go to normal CDF. The lower bound we stack from here, 0.609, and then the upper bound we go all the way to the right. So I just put a very huge positive value to represent the infinity, and then the mean is just 0.54 in the center, and then the standard deviation is this one here, 0.021, and we paste everything into the formula and we hit that, and you should get this value here. This is 5.08 times 10 to the minus 4. 5.087 times 10 to the minus 4. If I convert it back to decimal places, I should get 0.0005087. Right, 1, 2, 3, 4 to the minus 4. Okay. Remember, they ask you to display this answer in terms of percentage. So round the percentage. So this is in decimal. So if you want to convert it to the percentage, you have to move it to 2 decimal places to the right. So put the new decimal place here, which is 0.05087%. And if they want you to route to 2 decimal places, so 0.0 you can route to 0.05. Let me make sure that. So we have 5.087 times 10 to the minus 4. Okay, so you can route it to 81. Okay, and that should be the answer. And please note that here the reason that I did not get 0.06 like this correct answer, because I routed some value here, and that's why at the end we have some rounding error. If you keep the whole like 5-6 decimal places for this standard deviation and also for this ratio, then if you put that back in the TI-84, then you should get a better approximation of 0.06. So this is the correct process. It's just that try not to route that in the beginning, but only route the answer at the last step. And then if you do the same thing for the other two parts B and C, you should get these two answers.